Now we're going to learn how the LM555 timer works. This is, on the left, this is a photo of the LM555 timer in a dual inline pin or DIP package. This is a schematic of what's inside this plastic case here. Learning how exactly the insides of this thing work is beyond the scope of this course, but that doesn't mean we won't be able to use this timer. If we look at the pins for the LM555 timer, this is what each one of the pins are. So we're going to connect various things to the pins here, and we'll get a square wave at the output pin of this timer. The general way this will work is that we're going to use the LM555 timer in a mode that is called the astable operation, and in this mode the IC is going to act like an oscillator and produce a square wave at the output, as we mentioned before. The way that it does this is that the 555 timer compares two voltages at two different pins, and it turns the output on depending upon whether or not one of the voltages is larger than the other. And in order to create a voltage that's changing, we're going to add an RC circuit, or a resistor and capacitor, to the LM555. And when we do this, when the output goes high, so in the part of the signal, let me redraw the signal. So if we look at the output as a function of time, it will be low part of the time and high part of the time. So when the output is high, that will cause the capacitor to charge. Once the capacitor reaches a certain voltage, that corresponds to one of the voltages that the LM555 is comparing, that will trigger the output of the LM555 to go low, and then the capacitor will discharge. And then that process, so the voltage across the capacitor will start decreasing until we have the condition where the other voltage is now larger again, and so the output will go high, and that'll just repeat at a very specific frequency. This is what it looks like in more detail. So here's our LM555 timer. We're going to add some external resistors, resistor RA and RB, and external capacitor C, and this is the important capacitor here. So if we look at the output, or what's on the voltage coming out of pin 3, it'll look like this, sometime high, sometime low, and then that will repeat at a specific frequency. When the output is high, the capacitor will start charging. When the capacitor reaches a certain voltage, the output will switch low. Now the capacitor will discharge, so the voltage across the capacitor will decrease. When it decreases to a certain point, the output will again switch high, and the capacitor will charge up, and this process will repeat again. So what determines the frequency of that square wave output? So if you look at the data sheet for the LM555, you can find these equations. There's an equation for the charge time, or when the output will be high. That's given, that depends on the resistor RA, the resistor RB, and the capacitor C. There's a time that the output will be low. That depends on RB and the capacitor C. And if we just add this output high plus the output low time, that will give us one period of the square wave. Also, as you know, frequency is the reciprocal of t. This looks funny. This should be f equals 1 over t. and that's going to be equal to 1.44 over the quantity of RA plus 2RB times the capacitance C. So we can choose the values of RA, RB, and C to give us a specific frequency. Another thing to note about the square wave would be the duty cycle of it, or what's the ratio of the time that the square wave has a high output versus the time that it has a low output. So this is in a percentage, so the time that the square wave is high, we would divide that by the total period, and that would give you this relationship here. So we can use this to figure out what percentage of the time will that output voltage be a high voltage. And we're going to use these equations to design a circuit that will satisfy the requirements of a BalloonSat mission.